Okay, so in this video we're going to take a look at the other problems in your notes on how to create equations from the graphs. We're going to start off with problem number 4, which was the one that we got to in class but we didn't really finish. So we're going to go ahead and finish this problem up, or just start from scratch again. So we recall from class where if we're given a graph, you basically want to find your three values, A, B, and D. To find your A value, your amplitude, you take your max, 2, minus your min, -1, and divide it by 2. That gives us 3 over 2. For our period, B, we basically need to find the period, and the period goes from -3 all the way to 7. So we have 7 minus -3, we see that's a distance of 10. So because that period is 10, we know that b times our period, 10, is equal to 2 pi. So therefore b must equal 2 pi over 10, or pi over 5. So we've got a, we've got b, and now we've got to find d. So to find the d value, you just take again your max 2, this time plus your min was -1, and divide it by 2. That gives us 1/2. Remember that once you find that the d value, this represents your midline as well. So you want to graph that to be able to create your equations. So we're just going to represent our midline at the value of 1/2. Okay? Alright, so from here we can go ahead and create our equations. Let's start off with the cosine graph, since we basically do see that cosine shape to it. Looks like an upside down U. And it looks like if we wanted cosine, you can either start the cosine graph upside down, and it's important that you note where the starting point is, or you can have a cosine graph right side up, in which case the starting point would be more like the maximum. So it's your choice. In this case, I'm just going to go ahead and create the cosine graph that represents that maximum, and it'll just make my way down like that, so my cosine graph will look like that. Okay, so to do that, since cosine is right here, my starting point, it looks like my c value will just be 2. Okay, so let's go ahead and do that. For cosine, we're going to make c equal to 2. So we go ahead and write our values. Y equals, the a value is 3 over 2. And notice that the cosine graph is upright, so my a value will stay positive. Cosine, the b value is pi over 5. And then in parentheses, we're going to have x, and then since our graph shifted right, I know I should have x minus. My c value, where it's starting from, is 2. So I have x minus 2. And then my d value is positive 1/2. It goes up 1/2. So there's my equation if my graph had shifted to the right 2. Basically what I did was I did a cosine graph like this, and then the -2 was saying take this entire line and move it over 2 units to the right, and that's the graph that we formed there. Okay? Alright, so let's go ahead and now find our sine graph. To find our sine graph, this is where we need to take into consideration that midline, because the sine graph, it needs to form that S shape, and the S shape occurs along the midline of your graph. The starting point is on the midline. So our starting point, as we see, is actually right there. We need to find out what that point is, because from there we can see that basic sine shape, like that. Okay, oops. So let's go ahead and find out where that point is. Now to do that, oops, I shouldn't have erased that actually. A normal sine graph, if you look at it, we said that there are actually really important parts to this. Here's one, the starting point. Here's another, here's another, here's another, and here's another. So what we see is that this graph is actually broken up into 1, 2, 3, 4 equal pieces. So that's really important to note. The same thing goes for a cosine graph. If you have a cosine graph, and this is where you end, it has the same important points. And when you look at it, you can still break it up into 1, 2, 3, 4 equal parts. So we want to consider how a period is broken up into 4 equal parts. Well, we know what our period is. The period was a length of 10. So because our period was a length of 10, basically we're taking our 10 and dividing it into 4 parts. This is going to be a length of 10 over 4. This is going to be a length of 10 over 4. This will be a length of 10 over 4. And this will also be a length of 10 over 4. So if we think about it, 10 over 4, that just reduces to 5 over 2. So really, each distance is a length of 5 over 2. So what we can say is that if this is where we're at, the 2, if we go back 5 over 2, then we will be at our next important point, which is going to be this middle point. If we go back another 5 over 2, then we'll be at this important point. So going back each quarter will always give us that next important point. So if that's the case, to find sine, what we can say is that the c value, if we're right here at 2, we can go back 5 over 2 to then create our starting point for the sine graph. So c is going to be the same thing as taking the 2 and going back 5 over 2. And 2 minus 5 over 2, that gives us negative half. So our c value will be negative half. Okay? So now that we have the c value, negative half, you can see normally a sine graph would be right here. And if we go back negative half, we'll be right here. And now we have our new sine graph like that. Okay? So we can go ahead and put that into our equation. Y equals, it's an upright sine graph, so our a value will still stay positive. We have sine now. The b value never changes, that's pi over 5. And then we have our x value. Since we're going to the left, we need to represent that going to the left, and that's going to be positive. X plus 1/2, okay, because we went left half. And then we have our d value, plus half as well. So that's going to be our equation for sine. Okay. Again, you can rewind the video if you need to really make sense of how you can calculate that c value, showing how you have to go back a certain amount. Really, it's taking your important points and dividing it into 4 equal pieces. Okay. Let's take a look at the next problem. So here's problem 5. Here on our graph, we again need to find our a, b, and d values. So let's go ahead and do that. A, b, and d, find the amplitude. Amplitude is taking the max, 3, minus the min, negative 1, and dividing that by 2. That gives us 4 over 2, basically 2. The b value, the period, so we look at our graph. Oh, look, this is a very nice curve. It forms an upside down cosine. So we can take this as our starting point, and this is our ending point. It starts at 0, goes to pi. So the period is pi. If the period is pi, we say that b times pi is equal to 2 pi. Therefore, b is equal to 2. Just dividing both sides by pi. Okay, so we got our a and b value. Now we need to find the d value. So to find the d value, that's the vertical shift, up or down. So to do that, again, we can take our max. Remember that it's going to be added to the min, which is negative 1, and divided by 2. So 3 minus 1 over 2 gives us a d value of 1. Or, just to show you different methods, remember we can also say that if you take the max minus the amplitude, you can also get that d value. So the max was 3 minus the amplitude of 2, and you see you also get 1. Okay, so our d value is 1. Remember that 1 represents the midline. Show that midline on your graph, like that. Okay, show that dotted line. That dotted line is really what helps you create the sine equation, because you need that starting point along the midline to actually find that c value for the sine. Okay, so now that we have those pieces of information, we can go ahead and create our graphs. Let's start off with cosine. So for cosine, we said again that cosine graph, it looks like there is no horizontal shift. So let's go ahead and create an equation where there is no shift, which means c would be a value of 0. So then that just makes it pretty easy. We just say y equals, the a value is 2. Remembering that the cosine graph is flipped, so it'll be a negative 2. And then we have cosine. Our b value is 2 as well. And then we have x minus our horizontal shift. It's 0, so we don't need anything. So just 2x. Or you don't even need parentheses, actually. You can get rid of the parentheses and just say 2x. And then we have our vertical shift, which is going up 1, like that. Okay, so that equation, it was pretty easy to find because there was no horizontal shift. But let's say we actually did want to shift it. So let's take our upright u, which would be located right there. If we need to do that, remember what we can do is say we know a cosine graph is broken up into 4 equal parts. My period is pi. So if this is pi, its 4 equal parts will break pi up into fourths. So this will be pi over 4, pi over 4, pi over 4, and pi over 4 distances for each of those amounts. Now, I see here that I definitely know that this is pi. I have 2 important points in the way. So I have to go back 2 important points. So if I take pi and I subtract 2 of my pi over 4s, or that's the same thing as pi over 2, then I see that I will be at a value of pi over 2. And that actually does make sense, right? Since this is a period of pi, halfway in between, that'll be a distance of pi over 2. Okay, so I can also say that my c value can also be pi over 2. Okay, so if my graph moves over pi over 2, let's create our equation for this particular cosine. Okay, so y is equal to, I have an upright cosine. So since it's an upright cosine, I'll have a positive a value. Cosine, b value never changes, but this time I will have a shift. I am going to the right pi over 2, which means I will have minus pi over 2. And then my d value makes the graph go up 1, so I say plus 1. So there's my cosine equation. So let's go ahead and create our sine equation now. Okay, so for sine, let's do this in purple now. So for our sine equation, the sine graph, again, needs to have that midline value. The problem is that midline value, it's right there, or even right here. Okay, probably what would be easiest to find, I already know that this is pi over 2, so I need to go back another pi over 4. Okay, so if I go back another pi over 4, then pi over 2 minus pi over 4 will give me a distance of pi over 4. So that's going to be my c value, pi over 4. Okay, so I'm going to go back pi over 4. I see that this is going to create my sine graph that will be an upright sine. So I create my equation, y equals, since it's an upright sine graph, I know my a value will be positive, so it'll be a positive 2. Sine of the b value is always going to stay the same, so 2, and then x, and then since my graph, normally my sine graph would have looked like this, however now it's shifted over to the right, so I'm going to have minus pi over 4. And then again, my graph goes up 1, so I have plus 1, like that. Okay. Let's go ahead and go on to the next one. Number 6. Okay, so it looks like over here we have our equation, and now we need to create our graph. So let's label all the important points of what we're given here. -4, that tells us our a value is -4, meaning that the amplitude is 4, since amplitude is the absolute value of it, but the negative is telling us that our graph will be flipped. Okay, what else do we know? We know that the b value, this value in front, is really like a 1. So since b is 1, b times 1 equals 2 pi, which means that, oops, I wrote that wrong, sorry. 1 is the b value times the period equals 2 pi, which means that the period is 2 pi. That's helpful information. And lastly, we know that the d value will be this number here. Really, we see it in the back, but right now we see it in the front. So our d value is plus 3. Okay. All right, so from here, we can go ahead and start creating our graph. Now, to create our graph, since I know that the d value is 3, that's my midline. Let's go ahead and draw that midline in. So 1, 2, 3. Actually, this graph is not going to be drawn to scale. Based on the numbers I see here, let's just go ahead and say that 3 is right around here. Okay, so that's 3. Let's see what else. Since I know that the d value, the midline, is 3, and the a value is 4, or rather the amplitude is 4, I'm going to go from 3 up 4, and also down 4, which means my maximum will be 3 plus 4, or a maximum height of 7. If I go from 3 and go down 4, I'll get a minimum of -1. So that's why I didn't really draw it to scale, because I did see that, okay, I'm going to get a really big number here. So let's say that up here we'll be at 7, and down here we'll be at -1. Okay. Let's see, what else do we also know? Oh, this was pretty important. X minus pi. That tells us that it's going to shift right pi. Okay, so that's pretty important. So we're shifting right pi. Okay, well, if I shift right pi, then let's just say that right here is where my graph starts. I shift right pi. Okay. From here, we can go ahead and just draw our sketch. We have a cosine graph, so from pi we will either look like this or look like this at this location right here. Okay, we know that the graph is actually flipped, so we can actually rule out the upright u. It will look like an upside down u. So from here, what I can do is say, okay, I know my min is right here at -1. My max will be at 7, and I want to form a u. Actually, that's a bad u. Let's create a more elongated u, like that. Okay, and so we basically show our general shape. From here, the rest of this is just labeling everything and making sure that everything is exactly where it should be. So basically, if we know that the period is 2 pi, and I'm starting at pi, then pi plus 2 pi will mean all the way over here at the very end of a period, I will be at 3 pi, like that. Okay. What we also know is that since we break this up into fourths, we said that how every single graph can be broken up into fourths. You have this point, and this point, breaking it up into fourths. So know that I have a period of 2 pi. Then if I break that up into fourths, then this will be 2 pi over 4, 2 pi over 4, 2 pi over 4, and 2 pi over 4, which means every interval is a distance of pi over 2. if every distance is an interval of pi over 2, then here's my important point. I'm going to add pi over 2 from pi. Okay, so I'm actually going to do my calculations down here. If I'm at pi and I add pi over 2, by using common denominators, that's 2 pi over 2 plus pi over 2. That's the same thing as 3 pi over 2. So here, this value is actually going to be 3 pi over 2. Then from 3 pi over 2, I add another pi over 2. So 3 pi over 2 plus pi over 2, that'll give us 4 pi over 2. 4 pi over 2 is the same thing as 2 pi. So at this location, I will be at 2 pi. Okay, once I'm at this 4 pi over 2, again, I can add another pi over 2, and that'll bring me to my next location right here. So 4 pi over 2 plus pi over 2 gives me 5 pi over 2. This part right here is 5 pi over 2. And just to double check my work, if I have 5 pi over 2 there, and I add another pi over 2, then that's going to give me 6 pi over 2, and 6 pi over 2, it is 3 pi. So I have broken this up into 4 equal pieces. That's what I want. Okay? And you need to make sure that you show each of these 4 equal pieces when you are drawing your sketch. Okay? So I think that concludes everything on graphing. We'll take a look at number 7 on Monday. Okay? Again, rewind, watch, and rewatch if needed, and make sense of these graphs. If you have any trouble, then just let me know in class on Monday, and we can go over this. Okay? All right. Well, have a good weekend.